You want to say hi to all the absent people? Say hi.
Hi.
Okay, here we go.
Where? I'm just kidding. I'm recording now.
Okay, so I want to comment on what you worked on the packet and the type of problem that you ran into that would have bothered you some. If I said, hey, listen, I've got 500 milligrams of a substance that is being cut in half every couple hours, how long will it take to get to 200? I would have a variable here, and the only skill we have to find that answer is what? Guess and check. And the problem is that has massive limitations. So someone came along and said we need to fix that problem. And so in doing so, they created a function. Now, there's some historical background there that in the long run we're going to emphasize a little later, but what I want to say today about this is there has to be a way to undo that exponent, if you follow that nod. Okay. Give me an example of how to undo when you first learn equations. How do you undo addition? And then you pick it up a couple notches. How do you undo a square? Square root. Well, there is no skill we have to move an exponent out. And yet, follow me on this. We consider addition and subtraction what kind of functions? Inverse. And if we wanted to think about a square and a square root, don't they undo each other? With me on that? And if we have an exponential and we need that undoing, someone came along and created what we're going to call a logarithmic function. Okay, so out of what I just said, let's just come up with the basics. Why do we, in the first place, need a new function? Repeat the gist of what I just said. Why? Because the guess and check isn't going to work. And why can I not, what do I not have as a skill? I can't get the what where. Stupid question I just asked, but whatever. Run with it. Where is the variable and why is that a problem? I got a variable and an exponent and I have no what? No good way of getting it out. Okay. So if a subtraction undoes addition, you're going to repeat this for me. And square root undoes a square. What do we call those functions? Those are inverses. They undo each other. We're now about to create the inverse of an exponential. Okay. You generally get that idea, raise your hand. Okay, here we go. To do this, we're going to start with our most basic exponential function. We're going to use y equals 2 to the x. Now, really quickly, you should be getting pretty decent at this. We've done 2 to the x itself at least 5 times. I am going to create the table of values, and we already know because we've done this a bunch. My x values run from -2. And if you're really good at this, -2 is? -1, 0, 1, 2. Okay. So will you please plot these? Plot those there, please.
Lopez.
Okay, so you should be plotting these 5 points. And the plot of these is going to become pretty important here in a minute. I'm going to review as a reminder. No. Is that an appropriate graph?
Oh, no.
No. I need to make sure of what things, multiple. Why is this not an appropriate graph, Aaron? It also doesn't show what?
The rest of the line.
Yeah. I need that curve to be shown in both directions, going up and towards 0. Is that an okay graph? No. What's wrong with it?
It's missing.
The dash line.
The dashed line, which is called a what?
HA.
It is called an HA, more specifically a
Horizontal
horizontal asymptote. Okay, so we've been getting in the habit of this. This is going to be on your quiz on Tuesday. For the record, when I go to list off that table, what have I also been asking you to write? Characteristics. The domain is. The range is. The HA is
Y equals 0.
y equals 0. Notice she gave it as an equation, right? If you don't give it as an equation, you're not getting full credit. And the y-intercept is
0, 1.
0, 1. Now, before we start to talk about the inverse, I want to put some words to x and y. These values are going in for the what? Where am I putting these values? This is not overly complicated. Where is -2 going to get my y value? That's a better question. I'm putting -2 in the exponent. I want you to label this. The x's are my exponent. And for simplicity's sake, we're just going to call my y my value. Okay. But we said we need an inverse. And I have an original. So how do I find the inverse? Let's just say the points. How do I find the points of the inverse, Tom?
You just switch.
Flip-flop. Okay, here we go. Literally, we're going to flip-flop. So, -2 1/4 becomes 1/4 -2. 1/2 -1. 1 0 2 1 and 4 2. But conceptually, my x and y have just flipped as well. Which means my y values are now my what? Yeah, yes, but
Exponent.
thank you, very good. My exponent. From my other table, my y values are my exponents. And my x, kind of a weird word, but it's just my value, my input value now. It was my output value before, now it's my input value. Now, ironically, you're going to be surprised how, even though I might not have a picture of what this graph looks like, I actually know these characteristics. What is my domain? Nope.
1, 2.
Think that through for a minute. If I have the inverse compared to the original, 0 2. Why?
Because it rotates on y equals x.
That's partly why. That's a great answer. But there's another, something over here. Right here, over here. If your x and y are switching, your domain and range are switching as well. So this range is now my domain. Now, what's my range for my new one? Negative infinity to infinity. What is my new y-intercept going to be? Wait, there isn't one, but doesn't 1 0 or 0 1? Oh, it's 0 1. Doesn't 0 1 tell me something? 1 0 isn't a y-intercept. It's now a what? X-intercept. So following that same pattern of thought, this horizontal asymptote at 0 is now going to be a what? Vertical asymptote at x equals 0. Notice I have not even plotted a point. And just because of everything we did with chapter 6, I know all this information. Anyone find that kind of cool?
Sure.
All right, so do not connect the dots. Just simply plot the points. Go. Do not connect the dots. Just plot the points. So as you plot the points, I want to go back to what Ethan said a second ago. What do you instantly notice? You should. Yes. You should see the reflection about the line y equals x. Now, together, we're going to connect those dots. For the record, we'll talk more about this in a minute, but also out here, just so you can get a good graph, is the point 8, 3. If you want to get a decent picture. This is coming down here, getting closer and closer to 0. There's my vertical asymptote. But what have we not written down yet? The what? Yeah, actually it's a good idea. That wasn't what I meant, but I like drawing that on here because I do think it's healthy to see. If I actually drew the line y equals x, I can see that reflection. I'm going to go back to this, though. What is it that I haven't done at all? I've done points, I've done concepts, I've done characteristics. I have no equation. Okay, so here's where we're going to hunker down in the middle of our picture here. Okay? On your test last week, which, by the way, you will get next week. What is the rule to find the inverse? If my original, remember we did this a million times, if my original is y equals 2 to the x, how do I find the inverse? What's the rule?
Switch the y and x.
And then solve for y. Okay, so this is where this starts to get super dicey. So are you watching? Yeah, up here. So I'm going to do exactly what Ian just said. I'm going to switch the x and the y. And then what? Okay. But isn't that our problem? Our problem is how do we solve when my variable that I'm trying to get out is stuck in the exponent? So here's the fundamental concept from section 7.3. Someone came along and said, I am going to define what is happening here according to a logarithm. What I need to solve for is y. Notice y is my exponent. And my exponent, which is what I need to get out in the first place, comes from the log of x base 2. Some people will say this as log base 2 of x. I've heard it both ways. How'd you learn it, Mackenzie? Yeah. I learned it log of x base 2, but yeah. I think most people say it now log base 2 of x. Now, a couple things. I am telling you, just to as your teacher, that these are considered equivalent statements. But I'm also telling you that a logarithm is an exponent. Now, if I were to leave you with one phrase, it is that. Write this in big block letters. A logarithm is an exponent. So if you leave here today and you're like, hey, I really don't even get what we did, then all I want you to make sure you hang on to between now and Tuesday is a logarithm is n. Say it. A logarithm is n. Okay, so say the whole sentence. Okay, so on the next slide, the definition of a logarithm is there. And it says, hey, if I've got what we call a logarithm of y with base b, it looks like this. And so y's or x notwithstanding, it doesn't matter. Point being is, if I have log base b of y equals x, then b to the x equals y. Why? Because a logarithm is an exponent. And this notation says that this number to that number is that number. Now, a couple things. We refer to these as two different forms. One is called logarithmic form, where you can see log base b of y equals x. Exponential form takes that logarithm, takes those equivalent statements, and rewrites it. B to the x equals y. Now, I don't remember how this goes, but it's some cheesy little snail thing that if you find someone and they're like, it's a snail. I don't really remember how the snail is drawn, but basically b goes to x, which is y. I don't think that's a snail, but it's cute. So b goes to the x power and equals y. You with me so far? So what I'm going to give you time on your own later. Thank you. It's not a snail. I just don't know how it works. However, it's cheesy and it's cute. So here's what we're going to do with it. We're going to take forms and we're going to go back and forth. So, for example, this is considered logarithmic form. It's really a tricky concept. You know why it's called logarithmic form? It has a log in it. See? Log, logarithmic. Get it? Shocking. Does that have a logarithm in it in letter B? No. So is that logarithmic form? No. Look, you're learning something. All right. So if I'm in logarithmic form and I ask to get into the equivalent other form, watch this. This reads log base 3 of 9 equals 2. Why? Because 3 to the second equals 9. Now, it's going to take you a while. I mean, right now, that just more is like a pattern I'm teaching you, but eventually you're going to get good at seeing what a logarithm is. Okay, so because it's super easy, can you do C next? And just raise your hand when you have an answer. Go. Follow the exact same pattern, please. Got it? One person, 2 people, 3 people, 4 people, 5 people, 6 people. Okay, Sarah, go.
5 -2 is
Okay, isn't it? 5 raised to that outside power is 1/25. Okay, now, sometimes the harder way is going backwards. Exponential form is here. Now, I'm telling you how I think of this. Would we not call that the base? Everyone agree that's an exponential that has a base of 7? Okay, so first of all, just go log base 7. What is my exponent in 7 to the 0 equals 1? Okay, so my big, huge phrase that I wrote down a second ago is a logarithm is an exponent. Okay, so this is an exponent. Right? What goes right here? 1. You got it. Okay, so will you please do letter D, please? Okay, if you got letter D, raise your hands. Good, good. You got it? Try harder. Base 3 of 243 equals 5. Got it? Okay, question. If this number is 1, what is my exponent always? Oh, I heard, yeah, good. It's 0. Why? Because I don't care what the base is. If it's raised to the 0 power, what's my answer? 1. Make sense? Let me say it again, Tom.
No, I got it.
Okay, what if these are the same number? For example, look at letter E. I bet you know what this means, right? Why is log base 8 of 8 1? Because, yeah, equals 8, right? So if these are the same, what's my answer? 1. Why? Because this is saying, hey, what power am I raising that little b to get itself? 1. So what you're being introduced to on a really low-key scale, you're being introduced to this idea of properties of logs. And we're not going to emphasize them too much yet. But you hear how all of a sudden you can start to see patterns in logs of which you just learned about 15 minutes ago. Go to your next slide, which is at the bottom of your page. The last thing we're going to leave you with today are these 4 problems. This idea of evaluating. Now that feels weird likely because you just learned it. So how do you evaluate this log? The trick is change forms. So if I were you, I'd circle the word evaluate and put off to the side that a good hint is to change forms. So if I give you log of 64 base 4, reminder, a logarithm is a what? Whoa, yo. A logarithm is an exponent. So I know that this is equal to some exponent. What exponent? The exponent that has 4 to what? No. To what power that gives me 64? Answer. Oh, and see, you've been wondering all this time? How come I need to know my powers? Here we go. Great. Okay. With someone right around you, will you please do B, C, and D? Now, you're going to start to get somewhat decent at these. But they do get harder quickly, obviously, than C and D. You sure cannot.
Yeah.
See ya. Okay, answer to B. Quick. What is it? 4. Now, if it didn't feel quick, you want to know why? It's because you don't have your powers. That's right. Okay, what's the trick to answering 4? Tell me what to write down. To the x. Yep. You got it. Okay? Now you can imagine, have I typed anything in my calculator yet? No. So you can see where some of these non-calculator questions are going to come from. Okay. I want you to pair up. You got a few minutes left. So will you pair up with the person next to you? I want to figure out what are you writing from C and D, and then how on earth do you figure these out? Because I'm okay if you want to right now use your calculator to help you with the powers. I'll show you how to check it with the log in a minute. But talk with someone really quickly to set up and try to solve C and D. Go. 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 Do it.
Oh, I can get negative 4.
Need help? Or you know what else?
Negative 4 and then.
Okay. I go.
Is it
It's
minus 2?
Oh, no.
X.
You got about a week to learn your powers really well. well if you lost it. Or if you never had that, for instance. I'll wander on this side, Mackenzie will wander on that side, you can ask me questions. Definitely the harder one here is letter D. Yeah. Nice.
Are you gonna put a test in?
Yes. And most of
Today?
you were hopefully. If not, it'll be over the weekend.
Were they bad?
Okay, for a chapter 6 test, I did not. I thought there are some that are more on the lines of solid and survivable. But for a chapter 6 test, that's okay. And then I had I had people ace them. So
Wait, are they
they're
in?
pardon?
Can we see
In
them?
a most idea, you can see your first 3 pages if you want to see that. Yeah, in a minute.
I'll just wait.
Okay, you ready? If you got answers to C and D, raise your hand. Good. Ella, set up C, please.
1/4 the power of x equals 256.
Okay. Harder is. Okay. Why is it negative, first of all? Because I flipped it. And 256 is a power of 4. Does anyone need me to say that differently? Kyle, talk. You want me? I know. This is what Abby does when she's zoning out. It's like this. Okay. So, a couple things. I think it helps if you think of this as, I'm gonna put this over here. If you think of this 1/4, watch, as 4 to the negative 1. It's just another way to think of it. Because Carter's saying, hey, look, this flips to give me this. So if I go like 4 to the negative 1 to the x equals 256, and I really know my powers, so I know 256 is 4 to the 4th, right? Then I can say, oh, well, then negative x must be 4. Okay? If you want like a really concrete algebraic way, that helps. Okay, let's talk about D. Let's talk about D. You want to set that up, John? Go.
Sure. So 57 plus 32 to the x is 32.
Okay.
And then, seeing as how we're trying to go down from 32 to the fraction, so it's
Yeah.
going to be 1/5.
Okay. If you see it as 1/5, raise your hand. If you would prefer an algebraic way to prefer that, raise your hand. Okay. So what you are essentially always doing is connecting bases. So what I mean by that is, how is 32 related to 2? It's a power of 2. 2 to the what? 5th. So similar to what I just said to Abby, if I say, hey, this is 2 to the 5th of the x equals 1, what do I know about 5x and 1? They are the... Hello. That should be easy. They are what? They're the same. Yeah, so what's the pause on that? So do you agree 32 is 2 to the 5th? Do you agree power to a power u? Multiply the power, right? So that means 2 to the 5x equals 2 to the 1st, right? So therefore, if these are the same, then 5x must be what? 1. So x is 1/5. That's right. Your final answer is 1/5. Which, if you heard Jonah's explanation, is a solid explanation. Okay? Alright. How do we feel? Look at your section 7.3.
When does this end?
Oh, we still got 10 minutes. Oh, then we're going to do one more thing.
Yay!
Yay!
It's 10 minutes?
10 minutes.
10 minutes, 12:04.
They still
Why is it
recording?
so long?
Yeah, I'm going to stop in a minute. But.
I bet.
Okay, section 7.3 is your homework. Okay, so here's what you're going to do. The first section, I just need you to get good at this. So you're going to do numbers 1 through 7 odd. You're going to do 9 through 16 all. And on the back 29. Let's just do 29 to 37 on. It's literally the steps we just worked on. Okay.
Wait, we went up.
Yeah. Okay, so we're gonna do one more thing, but I'm gonna stop the recording real quick. You want to say bye to everybody?
Bye.
Yeah, but I'll talk about that in a second. Why?